Hey there, everybody. I wanted to make a little video for you guys this week about the difference between data and evidence, since we're looking at both of those things. And one of the things that you're asked to do this week in your first project is support what your article has to say about its topic with evidence from the article. So what is the difference between data and evidence? Well, I'm making my video in a really cool place. I'm going to pan around and show it to you. It's the Christa McCullough Challenger Center, which is here at Framingham State University, where I actually happen to be for a week-long institute on climate change, which interestingly enough, we are going to be talking about at the end of our class. And if you don't remember who Christa McCullough was, you probably do, but if you don't, she was a teacher from New Hampshire that was sadly one of the members on the Challenger shuttle that exploded. So this is a really wonderful place. They have a Mission Control Center, and where I am is one of the areas that simulates the kind of experiments that scientists do up in space, namely on the International Space Station. So what a great place to talk about data and to talk about evidence. So what's the difference? You read a little bit about it this week. But there is an important distinction between data and between evidence. Data are the numbers. So when you look at your stories from Science Daily, take a look at the actual numbers that they got. Data are things like surveys, assessments, the numbers, how many people fell within a certain range or category. These are all the numbers that are collected from the experiments that were designed. Now, what do we use that for? Well, the data that we collect and that we gather is used as evidence. And evidence is what we use to support our hypothesis. So, for instance, since I happen to be taking a class on climate change, what is some of our evidence? Well, some of our evidence towards climate change is that we see a rise since the Industrial Evolution in global temperature. Now you have to be careful because that's not day-to-day changes. For instance, today in Massachusetts, we have one of our coldest days in the summer. So you have to be careful about data. You can't look at one data point to provide your evidence. When we talk about climate change, what we're looking at is not only data for the past couple of 100 years, but even data from thousands of years ago, because we get some unique ways to look at past climates through things like ice core samples. So, how does this apply beyond science? Well, one of the things that we took a look at was this evaluation rubric, which you guys use to evaluate a couple of different sources. What we read in our everyday lives, your opinions about climate change, your opinions about health, about nature, all of that came from somewhere, something you read. That's the data. So using something like that source evaluation rubric, the CRAPO tool, sorry, the acronym's not the best, I know, but using that helps us make sure that the data we're feeding ourselves, that we use as evidence when it comes to what we believe is valid, that it's been performed and verified by other scientists. So this is the connection between what we're learning about here in this class, the natural sciences, and how we can take that out and really start using it to make sure that everything we think we know from something that we read or were taught or learned. Some of those things are accurate for sure, but we need to start challenging ourselves. Some of those things might not be accurate, and how do we find what's accurate? Well, we got to go back to the data. We got to look at the research. So when you're doing your Project 1 this weekend, when the questions ask you about what's the data from your article, those are the numbers, those are the studies that have been done. And when it asks you about the evidence is, did those data or those data points, did those numbers end up supporting the scientist's hypothesis? Or even more importantly, and what's great about science is when you're wrong, it's really great because you've got to go back to the drawing board. Did some of the data that they collected end up not supporting what they thought was going to happen? So I hope those 2 points have been of interest to you, and I hope everyone has a great weekend. See you on the discussion boards. Bye.